Hi, welcome to this channel. In the previous session, we were discussed the compounds of group 17th elements. The group 17th elements are nothing but halogens. Halogens are fluorine, chlorine, bromine, iodine. So these fluorine, chlorine, bromine, iodine, they forms a very interesting compound. The compounds are nothing but interhalogen compounds. So these are the subordinates of halogens. The halogens, they undergo reaction with another halogen, or internally the halogen and halogen, they react together and forms a very interesting compound. These compounds are nothing but interhalogen compounds. The word itself says interhalogen compounds. Halogen react themselves and gives a compound. If halogen react with the same halogen, then it becomes a diatomic molecule. That happens in ordinary condition, like F2Cl2 Br2. These are not interhalogen compound. These are the halogens. Okay. Whatever we know, the compounds chlorine, bromine, Br2. So these are not interhalogen compounds. These are the halogens. Okay, these are halogens. When halogen one halogen react with another halogen, or the compounds of halogens or halogen react with different electronegativities, then that compounds are nothing or called as interhalogen compound. Okay, example: ICl3 Cl F3 Cl Br3 Cl F, okay, BrCl. Okay, so these are the interhalogen compounds. So these are the example of interhalogen compound. What happened in case of interhalogen compound? One halogen react with another halogen, they forms a compound. Then how many types of interhalogen compounds are there, and what is the way of representation of interhalogen compound? Here there is a very interesting things. The interhalogen compounds are represented in four different way. Okay, let us discuss the interhalogen compound in details. So this concept is very important. Interhalogen compound is very important for your exam point of view as well as for your competitive exam point of view, because this part carries 1 marks in both the cases. Okay, or one question. Definitely one question is asked from this interhalogen compound, because in a higher level also, suppose you taken a chemistry in your higher study, then interhalogen compound play an important role. Okay, because of the reason of this is because they shows different types of uses and properties. Okay, they has unique property. Because of that, the part interhalogen compound is very important. The interhalogen compounds are commonly represented as halogen is represented with the notation X. Correct? Halogens represented using the notation X. X, X dash. Okay, this is the one type of symbolical representation as per your NCERT, or in other books or in different cases it is also represented in terms of X, Y. The X, one X, the first X, this one, is represented one type of halogen, and X dash or Y is represented another type of halogen. The halogen react gives an interhalogen compound. These interhalogen compounds are of four different types. The four different types of interhalogen compounds are X, X dash, or XY. So one type of interhalogen compound. Next, X, X dash 3, or in terms of XY, XY3. Next, another type is X, X dash 5, or XY5. And another type, last one, is XX dash 7 or XY 7. Okay, so these are the four different types of compounds, interhalogen compounds. Then what are the important things under the symbolical representation? We should remember the few things under the symbolical representation. The X, in case of XX dash or XY, the X's should be, okay, the first one, okay, this one should be larger in size. It should be larger halogen. Two halogen, they undergo combination. During the combination, the X should be a large halogen. Next, here also X is large and X dash is or Y. X dash or Y. Okay, this one is smaller in size, small size halogen. And when we observe the electronegativity, the larger size less electronegative, less electronegative, electronegative. It is more electronegative, more electronegative. Okay, let us study about these things. What are the interhalogen compounds are there? The first one, XX dash, and consider large halogen. Halogens are starting with chlorine, bromine, and iodine. Okay, here the large one is iodine, and when we compare these two, chlorine is bigger size, ClF, chlorine monofluoride, chlorine monofluoride, X dash. Here Cl is larger in size, less electronegative compared to chlorine. Chlorine is smaller in size, more electronegative. Yes, it holds good. Compound is exist because of smaller size of fluorine. Because of smaller size of fluorine, fluorine has ability to react with the chlorine, so they forms a compound, stable compound. Similarly, next BrCl. This compound is less stable. Existence of BrCl is very less because Br is larger in size, Cl is larger in size. Bond dissociation energy or bond enthalpy, dissociation enthalpy is low, existence is less. ICl is exist. ICl is exist. Next, IBr is exist because I is bigger in size. Because of that reason, it is exist. And also BrF, bromine monofluoride. So these are the interhalogens. Okay, because one halogens are there. Here tri, here penta, and F. Okay, so next XX3 form. In XX3 form, ClF3 exists because larger size of fluorine. 3 fluorine can attach possible. 3 fluorine attachment is possible. Next, similarly, BrF3 is possible. Next is ICl3 is possible. IBr3 is possible. Because these are the possible interhalogen compounds. In case of 5, IF5. Okay, next ICl5. And next 7, similarly IF7. Only one compound, IF7. If we are going to try to produce ICl7, is it possible? Chlorine itself is a bigger size, comparably bigger. When compared with the fluorine, it is bigger. Iodine is bigger. The chlorine, because of the larger size of or larger atomic radii, 7 chlorine can't attach or has not made strong bond with iodine. Suppose in your small hand, anybody tell you to take a 7 apple in your one hand. Is possible? Very difficult. So handling the 7 apple in one hand is difficult. Same thing happened in case of iodine. Because of larger atomic size of chlorine, iodine not has much of surface area to handle the 7 chlorine. Yes, ICl5 is possible. Okay, similarly IBr7 is not exist. Okay, IF7 is exist because of smaller size of fluorine, bigger size of iodine. 7 fluorine can easily make a bond, become a stable compound. It is not stable, therefore it does not exist. Okay, so that is the reason. So in all these things, that the same thing happen. BRCl is not exist because bromine is bigger size, chlorine is bigger size, so making the bond, the strong bond can't observe in this type of compound. Okay, so these are about interhalogen compound. These are the different types of stable interhalogen compounds. Then what are the different properties? The structural property. When you observe the structural property, in all these cases we observe linear structure. These are all linear. Linear means straight line with bond angle 180 degree. Next, XX3 dash. Okay, here we observe a bent shape. Okay, here we observe bent shape. The interhalogen compound with the form XX3 dash or XY3, they shows bent. This concept is very important. Okay, for your competitive exam point of view also, what may be the possible structure in following compounds or in this type of compound. Such type of question may be asked in your exam. Okay, x dash phi or xy phi. Here we observe the trigonal bipyramidal. Trigonal bipyramidal is not formed because of the hybridization. Okay, because of the hybridization, these compounds are more stable with the square planar pyramidal. Okay, these are shows square planar pyramidal type of geometry. Okay, so the geometry is square planar pyramidal. Next, here we observe pentagonal bipyramidal. Okay, pentagonal bipyramidal structure is or geometry is or shape is observed. Okay, pentagonal bipyramidal. So these are the different types of shape or geometry we observe, but some exceptional things are there. Okay, the exceptional things is because of the lone pair of electron. The VSEPR theory, according to VSEPR theory, we observe the few different types of structure under XX3 dash and XX5 dash type of compounds. Few exceptional things are there. Okay, so let us all this part will be discussed in the next part. Okay, next, the very important things under interhalogen compound is properties. Okay, what are the important properties of these compounds? The most of the interhalogen compounds exist in the form of a gas. Okay, most of the interhalogen compounds present in gaseous condition, and few are volatile solids. Volatile solids means in a room temperature or 298 Kelvin, 98 Kelvin. These compounds are volatile, easily evaporated. Okay, so these solids are volatile, and few are liquid in ordinary condition or in room temperature. Very few interhalogen compounds are liquid. Okay, most of the interhalogen compounds are gases. These are volatile solid means If we give or supply small amount of heat, then it get converted into gases, and liquid also get converted into gases. So therefore, interhalogen compounds are gases more than our ordinary condition or room temperature. Okay, next, color. Interhalogen compound shows coloring nature, coloring property. So different interhalogen compounds are different interhalogen compound has different types of color. Okay, most of the compounds are yellow and yellowish. Okay, and the iodine compounds are volatile. So this coloring property is because of the halogen. Okay, halogens are color. Okay, therefore these compound shows coloring property. Coloring properties are observed. Electron excitation, it is because of electron excitation. Next, the very important thing is all interhalogens are covalent. Important. Okay, all interhalogen compounds are covalent in nature. Covalent nature is because of, you can observe the here ClF. Okay, the electronegativity difference is very less. When electronegativity value difference is less, then the compounds are covalent. If the electronegativity value is more, difference is more, then they are ionic. Okay, for example, sodium chloride. Sodium is electropositive, chloride is electronegative, so the difference between electronegativity is large, hence sodium chloride is ionic. And in this case, electronegativity value is difference is less, because of that reason they are covalent in nature. Electron sharing take place. Okay, bond between the chlorine and fluorine, it is because of the sharing of electron. Okay, next, this one is important. Okay, they are covalent in nature. Next, another very important concept or important property is interhalogen compounds. Interhalogens are more reactive. What is the meaning of more reactive? Less stable. Okay, less stable, more reactive compared to halogens. That means when we compare ClF and Cl2, if we compare these two molecules, ClF and Cl2, ClF is more reactive, less stable. Cl2 is stable because of that diatomic state. The chlorine in its diatomic state is more stable. Similarly, fluorine is exceptional. Okay, only fluorine is exceptional. So here, except fluorine is more reactive. F2 is more reactive. The reason of more reactivity of fluorine, we observe the same thing in case of anomalous behavior of fluorine. The bond between the fluorine is, or bond dissociation enthalpy is very less. The reason of less bond dissociation enthalpy is fluorine is smaller size, another fluorine smaller size, fluorine atoms are smaller in size. Because of smaller size, inter-electronic repulsion, electron of fluorine, they shows repulsion. Electron negative charge, another electron negative charge, negative charge, they are repulse each other. Because of that repulsive force decreases the bond strength or help to separate, in another word, correct? So these two electrons helps to separate the atoms. That means bond dissociation enthalpy is less. Bond dissociation enthalpy less means more reactive, less stable. So this one is less stable, more reactive. The fluorine is more reactive than interhalogen compound, and interhalogen compounds are more reactive than other halogen except fluorine. Okay, so this concept is very important. Okay, you should study all these things point to point. Okay, because these concepts are very important for your exam point of view and also not for your knowledge point of view. Okay, so, there is no correct order or a systematic order. A lot of assumptions are there, and different things are observed in all these compounds, halogen and interhalogen compounds, and that's why the one marks question, mainly one marks question, is asked from this part. Okay, the possibility of asking the question is more in this part, therefore this part is very important. So these are the important properties of interhalogen compound. The very interesting topic of interhalogen compound is the structure of interhalogen compounds. Okay, let us discuss by considering different examples. And consider ClF3, or you can consider BrF3. Both have same a similar property. In structural property also same both the case. Cl F F. Okay, it is according to VSEPR theory. According to VSEPR theory, chlorine contains two lone pair of electron. What it says, the VSEPR theory says that there is a repulsion between bond pair and bond pair and lone pair. The lone pair repulsion LP and LP is more than LP and BP. Lone pair repulsion is more than lone pair bond pair repulsion, and bond pair repulsion is very less compared to lone pair electron. Here, in the structure of ClF3 or BrF3, if BrF3 is there, then central atom is Br. The Cl or Br, the halogen, central halogen, contains two lone pair of electron. Because of this 7 electron, okay, 1 2 3 4 5 6 7 8 9 10 electron system is observed. The S2 P5. Okay, so because of that availability of electron, it shows 10 electron system. In the 10 electron system, two pairs are observed, two lone pair electrons are observed in this type of compounds, X-3 compounds or XY3 type of compounds. Here we observe more lone pair repulsion, and bond pair repulsion is less. Because of that, these two bonds just congested or goes inside. Okay, goes inside. Therefore, the P shape, actually in ordinary condition, it should shows a T shape or T shape of structure, but we can't observe that type of structure or geometry or shape because of lone pair electron. So these type of few different things we observe in the structure. In case of another, okay, IF5, and I'm consider IF7 also. Central atom is iodine. Okay, next it should be a trigonal, sorry, square planar pyramidal, but it is not complete square planar pyramidal because of the lone pair. There is a lone pair electron in iodine. That lone pair causes the lone pair bond pair repulsion. Due to that, its different types of structure or distorted structure is not systematic. Okay, distorted band, distorted square planar bipyramidal, similarly pentagonal bipyramidal. So here square planar pyramidal, and here distorted pentagonal bipyramidal structure is observed or shape is observed. Okay, I will give you one homework. It is just an additional part, okay, not in your syllabus. Just identify the hybridization of the interhalogen compound. Okay, this work for you. Okay, what is the hybridization? It is just additional, but it is very helpful for your competitive exam. Okay, if you know the hybridization of the compound, then they are very easy to identify the structure. And not only the structure, you can identify the correct geometry and the shape also. How many lone pair of electrons are there? How many bond pair electrons are there? On based on bond pair lone pair electron, what may be the structure, actual structure? What is the geometry and all that? Okay, that's why you should determine the hybridization of the interhalogen compound. I think all of you able to identify the hybridization because you are already well known about the hybridization, determination of hybridization. In case of chemical bonding, we are already studied. Okay, in first year, by considering the electron configuration of the central atom and the other atom, so how they are combined based on the combination, how orbitals are overlapped, and how many lone pairs are there, how many bond pairs are there, and all that. Then what are the uses of interhalogen compounds? Interhalogen compounds are used in the fluorinating and fluorinating reason, or fluorinating property. So these are shows fluorinating and fluorinating property. In case of preparation of uranium UF6, uranium hexafluoride, it is obtained from uranium. When uranium is made to react with IF7, this one, okay, IF7, then they shows or they use uranium hexafluoride. So that indicates fluorinating agent, how they act as a fluorinating agent and all that. Next, the very interesting part is reactivity with water. X dash react with water, they forms HX dash. This concept is important. This one, smaller electronegative value or smaller electronegative atom, more electronegative, that means smaller size halogen form this type hydrogen hydride, and other forms HOX. HOX means halide, okay, hypohalite, okay, halite, hypohalite, halite, perhalite. So the different types of compounds are formed. Okay, let us discuss these things. If XX dash form interhalogen compound react, then halogen and halide, the halide X dash minus, for example ClF react with water, this is just additional thing. ClF react with water, then they forms HF. This hydrates of fluorine, in case of hydrates of fluorine, the fluorine smaller halogen or halide is react with hydrogen and forms a halide. Only if you consider this halide, fluoride, chloride, like that. Okay, halide and hypohalide, HOCl. Okay, HOCl. Oxoacids are formed, and XX-3 forms. They forms halide. Next, XX5 forms. They forms halate, and next perhalate, like that. Okay, so this is about the reactivity with water. Okay, next we move on to the oxoacids of 17 group elements. Let us discuss by considering the different examples. Oxoacids of halogens. Oxoacids of halogens. The oxoacids are of different types. From halogen, from fluorine, first one. Fluorine forms only one oxoacid. That part we discussed in case of anomalous behavior of fluorine. Fluorine shows only one type of oxoacid, it is HOF. And the next fluorine HOCl hypohalite chloride. Next HOBr HOI. Okay, these are the oxoacids. Not only this much, because of multiple oxidation state of halogen, they forms another type HOCl3, HOCl5, HOCl2, HOCl4, HOCl4, HOCl2, HOCl O3, HOCl, sorry, BrO, here HOIO, here we observe another one HOBr. But we observe all type of oxoacid in case of a chlorine. Okay, therefore this part is very important. Oxoacids of halogen, nothing but chlorine. Oxoacids of chlorine. Let us discuss by observing the structure of this compound. This structure of this compound is very important, as similar as that of oxoacids of phosphorus. That part you are already studied. Okay, HOCl. What is the structure? How to draw the structure of HOCl? Here, oxygen is the center. Okay, and the next chlorine. Next. Okay, this can be represented in another way. Same one. O at the center, H C. Okay, this is the best way to representation. Next, same H O Cl contains double bond O. One oxygen increases. Next, here HOCl, two oxygen, and another one is OHCl, here 3. So this is the way of representation of different types of oxoacids. Then what are the name of this compound or oxoacid? The first one is hypochlorine with oxidation number lower oxidation state, therefore hypochlorous acid. This one is hypochlorous acid. Next, this one is chlorous acid. Chlorous acid. Here chloric acid. Oxidation number increases, because of that IC. Chloric acid. Orthochloric acid. Orthochloric acid. Okay, so these are the name of the oxoacids of chlorine. Next, what are the important properties of these oxoacids? The acidic property. Which one may be the more acidic? Just observe here. In case of these compounds, when we increase the number of oxygen, then tendency of giving the hydrogen become more. Therefore, this one is more acidic. As well as central atom shows higher oxidation state. That part, the same part we can study in case of oxides of nitrogen. When the oxidation state of nitrogen increases in the oxides of nitrogen, then that oxide is more acidic. Lower oxidation state oxide is less acidic. Same thing happening. Okay, move down the group, acidic strength increases. And in case of different oxoacids, means HOF is more acidic. The fluorinating or fluorine oxoacids of fluorine is more acidic than the corresponding is same type of oxoacid. HOCl, HOBr, HOCl. So this is the acidic strength of different halogens, oxoacids of different halogens. In case of oxoacids of same or chlorine, the order of acidic strength is here less acidic, more again, more and more acidic strength is observed. Okay, these are the important properties of oxoacids. Okay, all things are very important. Please go through this video and practice about all these things. Okay, thank you for watching.